Steve Jobs once said, "You can't connect the dots looking forward, you can only connect them looking backwards." Since ages, in ancient India and the world, scholars of different disciplines have been trying to connect such things. Be it Newton discovering the gravity by just looking at an apple, or William Wordsworth writing a timeless poem on daffodils by just looking at them in his sister's garden. Hi, I am Vaibhav, and let's break a leg at one such junction of rhythm, petals, and maths. Now, let me introduce you to this handsome genius, Manjul Bhargava. So, Vaibhav, who is he? He is professor of mathematics at Princeton University, USA. He is a Fields Medal winner, which is the highest honor a mathematician can receive, and described as the Nobel Prize of Mathematics. Why not the Nobel Prize of Mathematics? Because Swedish Academy forgot to add one. And he's an admirer of Sanskrit poetry and trained under Zakir Hussain in tabla. Now, I came to know about this topic while he was giving a lecture in a school in India. And Professor Manjul, being an admirer of Sanskrit poetry, brought this forward in such an interesting way. You will see in just a couple of seconds. Now, the Sanskrit poetry has syllables, like it's the basic constituent of Sanskrit poetry is syllables. There are two types of syllables: the long syllables, which can be called the stressed in poems, and the short syllables, which are called the unstressed in poems. A short syllable lasts one beat, whereas a long syllable lasts two beats. This technique was used by poets in ancient India nearly 2000 years ago to compose poems, rhythms, tune, and anything. Now, you can ask me, how is that possible? Have patience, we'll see it soon. Now, for example, there are 8 beats left in the poem or any rhythmic composition. How many rhythms consisting of short and long beats out of the remaining 8 beats can be made? So one way could be long, 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 which is 2 plus 2 plus 2, 8. Another way could then be short, short, short twice, which again counts to 8 beats. And third way could be short, long, short, long, short, long, short, long, which will again count to 1, 2, 1, 2, 1, 2, 8 beats. And many other ways can be there. So the question we are asking is, if the number is say n, then in how many ways it can be written as sum of 1 and 2, if you remember it, short and long beat? Or how many poetic meters are there of n beats constituting of short and long beats? So if n is 1, so there will be obviously one way. If n is equal to 2, there will be one way, that is 1 plus 1. If n is equal to 3, there are 3 ways: 1 plus 1, another 2 plus 1, another 1 plus 2. If n is equal to 4, there are 5 ways. As you can see it on the screen: 1 plus 1 plus 1, 2 plus 1, 1 plus 2 plus 1, 1 plus 1 plus 2, 2 plus 2. Similarly, if n is equal to 5, there are 8 ways. So, the ancient Indian scholars came up with an ingenious way to obtain the general answer. First, write down the numbers 1 and 2. Each subsequent number is obtained by adding the previous 2. The nth number gives the number of rhythms having n beats. As you can see, 1, 2, 3, 5, 8, that is the sum of the previous 2, 21, 34, 55. So, if you remember the previous question which was asked, there are 34 rhythms having 8 beats. These are called Hemachandra numbers, which are named after Hemachandra, a linguist and polymath, who was the first who documented them and proved their recurrence property. And Vaibhav, what do you mean by a polymath? The thing is, I just stumbled upon his Wikipedia page, and as you can see, he was an Indian Jain saint, scholar, poet, mathematician, philosopher, yogi, grammarian, law theorist, historian, lexicographer, rhetorician, logician, prosodist. So I thought just writing a polymath may save our time. Anyway, The Hemachandra numbers are also known as the Fibonacci numbers in the West. And please do look on the fact that Fibonacci was born 100 years after Hemachandra. Now coming to the Holy Grail, why Hemachandra numbers work. So his argument was that every n beat rhythm, and by rhythm you can take up like music composition, poems, and any tunic thing, if that's a word. So yeah, every n beat rhythm ends with either 1 or 2. The general equation comes out hn is equal to hn minus 1 plus hn minus 2. The Hemachandra number or the Fibonacci numbers now form the basis of huge mathematical and artistic theory, which you can see in many forms like poetry, architecture, visual arts, and the favorite one, the nature's art. Now, to prove upon the nature's art and the application of Hemachandra or Fibonacci numbers in it, I actually took the pain of going to my terrace garden to find out flowers and petals as it was mentioned in the title of the video, which would allow me to show you the magic of these numbers. But sadly, it is the summer season and roses and a couple of other plants with flowers were not on their full show. So I am forced to take few pictures from the Google. By the way, if you find some beautiful pictures in real life, you can send it to me. So here it is. Zinnia flower in the International Space Center. As you can see, there are 8 petals, which is in fact a Hemachandra number. 21 petals in a sunflower, which is again a Fibonacci or Hemachandra number. You can count them also. And many such examples in nature like 1 petal and 5 petals, 3 petals, 8 petals. And if you take a look at this daisy, it has 55 petals. And why I know this, because I counted them, which is again a Fibonacci number. And if you closely look to the seedlings, they are arranged in the spiral, which is actually the most compact way they would be arranged. And they are also arranged in a sequence or a number which is called the golden ratio of 5. Another such magical example is tals in tabla. So if you have some knowledge in tabla, which I am lucky to have because of having a Prabhakar, there are 6 tals. So tals in tabla, which is further used for synchronization of vocals and other musical instruments, so as to be when people say that to be in beat or lay. They are also happen to be arranged in Hemachandra numbers. The tals being Teen Tal, Dadra, Kairava, Rupak, and few more. To further read upon them, there is a research paper by Rutgers University that titled Fibonacci Numbers in the Music and Meter of Indian Music and Poetry. You can read it, the link is in the description. But why read them when we have the man himself, Professor Manjul Bhargava, demonstrate it to you? So here it is.
When you make a complete circle is always a Hemachandra number. Are questions that still come up today, and for example, in music. So, for example, they come up tremendously in drumming, which is one of the reasons that I first got interested in these numbers. If this tabla works, maybe I can. So there may be a part of the piece where long and short is the rhythmic motif that's being used. That happens often. So, for example, in tabla, often you'll have longs and just compositions that involve only longs and shorts. Now, that may seem very restrictive, but as we just saw, even with 8-beat rhythms, there are 34 ways of combining longs and shorts into 8 beats. And so for example, a long might be hatigene, and a short might be dhine. And so you can play 8-beat combinations of just those 2 phrases. So,
Marvelous, right? From one of the greatest mathematician alive in our era. There was this another video by Srinivasa Kologi on YouTube which you can check out for some better understanding of the same application of Fibonacci series in tabla. So here we come to the conclusion. The Fibonacci series or Hemachandra number in the daisies can be a coincidence for you or a magical revelation for now. Thank you very much for watching. Here ends my first video and I'm really sorry for any glitch or anything you don't like because it's my first video and I'm learning. Please feel free to write to me for any suggestions or improvement which could be there. Once again, thank you very much for your precious time. Take care. Have a great day. Bye.